everyone, welcome to Linkenite's first ever webinar. The topic of the webinar is creating humanistic Gen AI workflows beyond basic chatbots. So we have our speakers as Pravin Luthada and Tisha Singh, and they both will be sharing in detail about this topic. So I would request Pravin to the start the webinar, and then Tisha could take forward.
Awesome. Thank you, Jasmeet, for the warm welcome and the introduction. Thank you, everyone, for joining. And we hope that the session would be useful. The basic guideline would be we would start with just a brief introduction of the speakers and like a brief introduction of Linkenite. And then in the webinar, we'll be mainly focusing on to the why, how, and when to think about the Gen AI workflows for your organization that may go beyond the basic chatbots. Um, so, starting with the introduction, my name is Pravin. I'm CEO at Linkenite, mainly helping with the sales and marketing team. By trade, I'm an engineer. Used to be a space scientist, and then shifted on to supporting, seeing the AI revolution that's ongoing. Started the Linkenite along with the great team here. And alongside me is Tisha Singh, who is the AI lead at Linkenite. Will be also presenting the technical aspects of the workflows that Linkenite is able to support and build, and how to think about them once you would want to implement them in your organization. So, with that prelude, just want to give a brief introduction about Linkenite. Um, with Linkenite, the main vision has been to identify workflows in organization and try to use Gen AI to help automate these workflows while keeping the human supervision at at the at every outcome. So to be able to make sure that all the uh, AI workflows that are getting created are human supervised and are done in a collaborative manner. So that as being the main expertise of Linkenite. Let's kick off the webinar. So let's click on this button here. So let's start with understanding the LLMs. So the LLMs are mainly this transformer technology that kind of kicked off this race, where if you would provide this transformer architecture with vast amount of data and train it and add some feedback loop or some human supervision at the end, what you end up having is a model that is capable of producing human-like text for a given query. And that got kicked off by ChatGPT as a main application window to the world. But now there are many, many more players. Google with their Gemini, Anthropic with their Cloud A models, and there are even search bots like Perplexity, and then there are open source model providers as well in this space, with the Meta being with their Llama models. Um, at the moment, the main impact these chatbots are having is showcasing the capability of how they can uh, answer to a given query, to uh, basically understand the context and provide an answer that feels so human like. And we start to use them almost on everyday basis quite a lot. um, let's try to understand very briefly how these chatbots work. So, as a user provides a query to them, they try to break down this given text into what you would call like embedding, vector embedding, and then they try to search in the embedding space, and then they kind of, based on their attention model, they try to predict what should be the next character that they should be outputting. And because the model is fine tuned to produce more human like answer, it generates an answer that is more based out of pattern matching and the understanding of the context based on its embedding space. So these responses are mainly coming from the training data that was used. So the data that was creating, or like the foundation of the embedding space. And some of these models now have the capability to also mm, kind of, you can call them memory, where they could store previous chats as well as such things to hopefully provide you a more refined answer over a period of time. Not all of them, but some of them. However, there are limitations with these chatbots. So there is a very limited understanding of the context. So as an engineer, when I have something specific to ask, I am often have to explain a lot before I can get a relevant answer, you could say. And if at all, if I'm able to, because it might be possible that that context might not be available in the training data, or may not be available in enough of the quantity for the model to have a context about this topic. And this kind of makes it, the model, if it doesn't have the answer, kind of also hallucinate a bit and try to come up with an answer, or sometimes just say no. And that's kind of is a huge limitation when, as a subject matter expert, you try to ask this model a particular query. Then the second bit that uh, is the, if a query requires the model to break down the task into subtask and then kind of go through not only one iteration but few before kind of finalizing the whole idea. At the moment, these chatbots are kind of not ever built that way. They were built as conversational bot, and they are not the best in being able to predict what they are able to should do, how to break it down, and then they should be iterating on it. So a human has to be there, kind of trying to do this iteration along with them, and most of the time unsuccessfully, still compute taking the compute but not generating. So there are these limitations that the chatbots face. So this slide basically provided us now the overview of the current chatbot space, and what are they capable of, and what are their limitations. um, the key question is, why do we want to go beyond this chatbot? So we'll be taking a use case here to kind of talk about it, that is marketing. um, for a given company, brand identity and what type of content they write is quite critical. That kind of defines this company or organizations, like a view from outside world. And they want to have that brand identity plus the tone in which they write and what type of content they publish, in to be very different than other people and other competing organizations. So you really want to make sure that the unique voice is there, the unique style of not only writing but color palettes and what type of messaging and such. And if you were to use one of these chatbots, you might find it quite challenging. You might end up having to go through um, the huge burden of basically ask it again and again and rewrite a lot of what this chatbot has provided. So customization is one of the key requirements why you should think beyond the chatbots. And there are a lot of benefits to this customization that's possible with the tailoring of the AI solutions that are there. So one of the key ones that kind of a marketing use case pops out is definitely the tone and the like voice of writing, how you want to. And then there is also the brand's own identity that you could reflect, and this you could already hopefully train within the model, so then it makes sure that it is going to follow that. And once again, being an engineer, I would like to have some formulas, I would like to have some charts or graphs that are more specific to this type of engineering audience or technical audience. So for that, I would like to have those, and these are possible to be included. It's just that the model has to be trained to understand that, okay, let's leave this space for certain this type of aspect here, even if it's not able to produce it from end to end, but it is able to go for it. And then not only to have this type of different types of what you can say, the data formats, so tables, charts, or graphs, but also have the technical jargons understanding. So a short form in a certain field can mean something, and in the other field quite a lot. So if you're a lawyer to an engineer to a doctor, there's a lot of technical jargon to go around between those fields altogether. And then definitely the benefit of being not only able to write in your own language, but then also go beyond. So at Linkenite being based in Finland, we have supposed to write more content in Finnish as well as in other European languages, which is used to be a huge barrier. But now with the customized model, which is able to understand the tone and technical jargon and such, is able to translate much better. So there are a lot more that this going beyond just basic chatbots can really help. Um, and this marketing as a use case help us understand that. So yeah, let's move on to understanding the technical aspect of it, and I will invite my colleague Tisha here to help with this.
All right. Thanks, Pravin, for the wonderful presentation so far. So we will be talking about the two main mechanisms that are out there in the Gen AI space. So a lot of applications have been developed based on fine tuning and RAG implementation. So we will cover fine tuning process, wherein we will talk about how to set up the data, how do you prepare the data, what are the requirements for data preparation. Then we will talk about what's the best pre-trained LLM model that you need to select and what are the criteria of selection for your pre-trained models. After that, we will talk about how does the actual training process works and what are the software and hardware requirements there. At last, once you have fine-tuned your model and you have your fine-tuned LLM already, then how do you evaluate the performance of the model? And once you found any lack in the performance, like for 80% of the use cases it's working, but for 20% use cases it's not, then we try to reiterate over the fine-tuned model and go through the process again. So we'll talk about all of these technical implementation in details. We'll also talk about implementation of RAG-based architecture. So this is a very famous architecture which is less resource intensive as compared to fine-tuning. RAG refers to Retrieval-Augmented Generation. So we'll talk about how do we set up our databases for the RAG architecture. How does the actual mechanism of RAG function? So there are two parts to this RAG-based architecture. One is retrieval mechanism, another one is generation. So we'll talk about both of these mechanisms and how does this architecture works. So there are a lot of things to kind of consider while you are actually utilizing these models, and especially in complex use cases such as financial applications where you want the LLM to act like an advisor to you, or healthcare applications where the LLM is suggesting you health-based tips. So that is something, and there are a lot of considerations that we need to take care of. So we'll move ahead and discuss more about the first topic, which is fine-tuning processes. Next slide, please. So let's talk about the process of fine-tuning. Fine-tuning basically refers to the process where you add an informational layer, an additional informational layer to the already present pre-trained LLMs. So those are the foundational base models that we already have. One such example is of Llama 2 and Llama 3.1, which are recent released by the company Meta. So these models are actually trained on a lot of raw text data. So if we talk about Llama 2, that's trained on 70 billion training parameters. So all of this raw text data that we have, it determines what is the capability of the pre-trained base LLM. So this raw text data is basically fetched from different internet sources such as Wikipedia, then different search engines. So Meta basically has a lot of these collection of these data that it has fed it to the model, and that is when the pre-training part happens. So once we have decided that, okay, this is the pre-trained LLM that we want, after that, we go to the next implementation, which is the fine-tuning part. Now, fine-tuning helps you in order to make the model super customized. So let's say you have a given use case, you have a general base LLM or foundational LLM, but now you want this LLM to understand the internal description of your organization, or how do you want the product to, what's the description of your product. So if you want to add this additional information and make the model learn about this description of your product or the description of your organization, how all of those things works, you can add an additional layer of custom knowledge base to this model. And that is where fine tuning comes into the picture. So then you fine tune the custom knowledge base and you get the actual fine tuned LLM. So let's move ahead and talk about the first step that is required for implementation, which is preparation of the data set. So we are all set. We have decided that, okay, we have to move forward with fine tuning, and fine tuning is the right GenAI solution for my given use case. So after that, we will perform data preparation. So data preparation is a very important step in LLM fine tuning, because whatever inputs you provide to the data, you get similar outputs. Garbage in, garbage out. That's a very famous concept in the GenAI space. So first step is data cleaning techniques. You need to clean your data. If there are any data anomalies, if there are any null values, removal of null values. So all of that process need to be performed. Once you have ensured that the data that you're providing is it's clean, it's very customized, and it's very relevant, then we move ahead to the next process, which is formatting the input training data that aligns with the model's requirement. So different sort of models have their own requirements of the format that is required for training. We will see one such example in the next slide. That is an example of OpenAI. So if you are considering that, okay, I have to treat GPT-4.0 mini or GPT 3.5 Turbo as my base model or foundational models, then this is the conversational chat format which OpenAI demands. So your data need to be in this given format, which is a JSON object that contains a key value pair. Over here, we have a role and a content. So for role, the role could be system, and then system provides its own content. Similarly, the role could be of the user, and you provide such key value pairs where you write the prompt, and you write what's the desired output that you wish the model to get. So this is the format that is required for the input training data set, specifically for OpenAI models. So after that, if you have you have cleaned the data, you have formatted the data in the desired format. Next step is selection of the correct pre-trained LLM for your given use case. So there are different parameters to the selection criteria. Like one model might perform better as compared to another model for a given use case. Let's say that, okay, I am using GPT-4 for code generation purposes or for data analysis purposes. So that might be the best model for this given use case and not Sonnet 3.5. But when it comes to generation of marketing content, I guess Sonnet 3.5 is the best model that performs best for this use case. So it depends largely on what is your use case that you want to fine tune the model for. So given that, there are three parameters that we need to consider while making selection of the base foundational LLM. One is model size. What's the size of the model that you are using? So as I mentioned earlier, different companies are coming up with different models every month. So one such recent releases of Llama 3.1. Llama 3.1 is now trained on even more larger data set. That is somewhere around 420 billion training data set. So the larger the model is, the massive training data set it accommodates, the more generation capabilities, the more efficient capabilities the model is able to accommodate. So model size is something to consider. After that comes the model architecture. What's the architecture of your model? So as compared to all other models that are now existing in the market, OpenAI is very much ahead in this race. So all the models at the very foundational level contains the same architecture like OpenAI, which is a transformer architecture. So we have encoder decoder architecture as well. We have self mechanism architecture. And some of these models are a hybrid, a combination of these architectures at different layers. So having an understanding of what's the architecture of your model and how flexible it is. But because when you are going to build on top of that, you need to understand what's at the base level of your GenAI solution. So that's another parameter to consider. After that comes performance for domain specific task. So as I already mentioned, how your model is performing for your given use case. Is it the best model for marketing content generation? Is it the best model for performing research work? So this is something that we need to be mindful of when we are making that selection for our base LLMs. After that comes the training part, that is training the foundational model that you have decided for fine tuning. So for training, there are some requirements, hardware level requirements, which is you need strong GPUs. The best GPU, which has a lot of capabilities and high speed GPU, is Tensor Core uh, NVIDIA H100C. It is the best GPU so far. It's very, if you are like dealing with a vast amount of data set, this is the best hardware support that you can rely on. There's also some memory and storage space that is required, which starts from a minimum cap of 24 GB if you have a smaller data set. If you have a larger data set, that might go somewhere around to 40 GBs of free memory and RAM space in order to train your models. Now we have prepared our data set. We have selected the desired LLM based foundational model for our use case. We have also trained it now. Then comes the last step. When you have the fine-tuned LLM ready, you go into the performance evaluation. You test your model on different parameters, different performance. If required, you kind of mold the arguments, like changing the temperature value slightly. Like if earlier my temperature was 0.25 and I was seeing some sort of gaps in the desired output, I might modify the temperature and make it, let's say, 0.5 this time in order to see the relevant changes. So that performance evaluation is something. Also, if for some of the given use case, you feel like, okay, for 20% of the time my model is not performing in the way I want it to, what you do is you go and you iterate over this fine tuning cycle. So you need not to, since fine tuning is a very resource intensive process, you need not to fine tune it from scratch. What you do instead is that you append the external knowledge which wasn't covered by the fine tune model now. So we append the external knowledge in the custom knowledge base and fine tune the already fine tuned model. So there are some of the specific libraries that support you in this process. They are aware of the fact that you have already fine tuned it, and this is the iteration of the already fine tuned model. And considering all of those facts, it's always good to reduce the number of epochs that you are mentioning for fine tuning. So let's say that you mentioned 13 epochs, 13 times the model will be trained on your given data set for the first fine tuning. Now, when you are iterating over it, let's reduce the epochs to 4 or 5, because this is the second time when you have just appended some more data and you want your model to cover rest 20% performance issue. So this is how evaluation and iteration is performed. All right, so moving ahead. Yeah, so moving ahead, let's talk about implementation of RAG. We have discussed fine tuning. Fine tuning and RAG are too much in demand nowadays for every application that you implement in the GenAI space. And there's a lot of conversation that is happening in the developer community of which model performs best. So there are pros and cons of each of these models, and they have their specific given use case. For some given use case, fine tuning could be the best solution. For other use case, RAG could be the best solution. So RAG is basically something that helps you to add an additional specific knowledge base that your model lacked previously. So this is less resource intensive to some extent as compared to fine tuning, and this basically is preferred. The RAG implementation is basically preferred when you want to generate answers that contain specific information which you additionally provided. So let's say that we want to generate marketing content, and this time my model should understand some pieces of content which I am additionally providing. It should understand how does like this particular concept of marketing works. So what I do is I set up my knowledge base and make it an external layer of information for the model. And this knowledge base, it kind of influence the ultimate result and output that is generated by the model. So that is what RAG is all about. Let's dive into the mechanism, how this actually takes place from a technical perspective. So you come to the RAG model, you provided an input, which is the question. So this prompt then goes to a smart retriever. So this is where the retriever mechanism comes into action. This retriever mechanism goes to your knowledge base and asks for specific kind of information which is relevant to your question. So it performs semantic search, semantic vector search. So if you have already stored, you have this model, you have stored this model, you have created vector embeddings for this and stored this into vector databases. This could be FAST database, Chroma database, or Milvus database. FAST is a open source vector storage database by Facebook, which was released even before the release of OpenAI. So it is a very helpful database for multiple use cases. So we send that question to this database. It performs vector retrieval search and it extracts the relevant chunk of documents from it and sends it back to the smart retriever. That, okay, this is the information that I got based on the question that you added. Now, after that, what happens is the smart retriever sends the question and the relevant document chunk to the LLM generator. And that is where the LLM generator part comes in. So for this generator, it generates the final output, which is influenced from the source information that you provided. So there's a lot of difference that takes place between a general solution that you generate. If you straight away go to Sonnet 3.5 model, the open source models are available, versus when you actually implement this RAG mechanism, because a lot of control now is in your hands. You can kind of implement your strategies there, and you can get the response in the way you want, and driven by the knowledge base that you are providing. So that was about implementation of RAG strategy. Moving ahead, let's talk about a very important aspect. So when you actually implement all of these solutions for different industries, some of these industries are very concerned about what are the ethical considerations in this space. So also, what are the best practices to consider? Because if you're considering all of these best practices while you are actually implementing the solutions, the performance of your LLM, it would be good depending on what kind of data set you have fed it. So let's talk about each of these considerations and best practices one by one. Starting with data quantity and quality. So what's the quantity of data that is required in order to get best results from these models? So generally, a sample training data set of somewhere between 100 to 100,000 examples is recommended. Now, this range of training data set is huge because it largely depends on what's your given use case. So if you want the model to perform a very complex task, a lot of computation, calculations, and mathematical calculations you want the model to perform, then a data set like that is when you reach the maximum cap of this, which is 100,000 sample examples. So that is when it is recommended to provide as many examples, relevant example as you can to this data set. ideally to see an impact in the performance of the LLM that you're providing. It's always recommended to have an example of somewhere around 500 to 600 training data set. So that's the quantity that is recommended for implementing like RAG strategies or fine tuning. Moving ahead, finding the task specific and relevant data sets. So the data set that you're providing to your model, whether for fine tuning or for retrieval augmented generation, that data set should be very specific and very relevant to the task you wanted to perform. So maybe if I want my model to act like a financial advisor, I will give it relevant examples of what the output that I wanted to throw, and how the actual process of arriving at a decision should look like. So the data set that you provide should be very relevant. In case you're providing any irrelevant data set while training the fine tuning models, there is a lot of potential for the model to hallucinate. So it's always recommended, in order to prevent hallucinations, it's always recommended to be relevant and be as specific, as concise as possible when you actually create and craft your data set, training data sets. After that, addition of data that doesn't fit in the prompt. So generally, we adopt the RAG and fine-tuning architectures and adopt that as a solution when prompt engineering fails. So there could be some complex areas where prompt engineering might fail. So you have added a long prompt to the model, and you have made it to go through all the instructions and everything, but still you feel like the model is not covering these use cases for me. So these are some of the cases that are missing. So add those pieces of content in your data that where prompt engineering kind of failed. So this is very important. Cover those use cases, write it down, and provide relevant examples which prompt engineering failed to cover. So this is another important best practice to consider when you are implementing your GenAI solutions. Moving ahead, talking about computational requirements. So the first, there are a lot of requirements at a hardware level and a software level for training all of these models. So we need multiple GPUs and even TPUs in some of the cases. So as I said earlier, multiple high-end GPUs. Best example is NVIDIA's H100. Is something that is preferred for faster execution and training. After that, we have considered the memory and storage space. Uh, like to consider the maximum caps, memory space of somewhere around 48 GBs is preferred if you want to implement any sort of training applications. So that is a computational requirement when you actually try to implement these solutions. After that, let's talk about the ethical considerations of these GenAI solutions. This is something which is very important, specifically for critical use cases of the healthcare industry, of the finance industry, and use cases where you need to be very precise about where and how the data of the users are getting, getting into. So, first point is privacy and data protection for sure. How do you like using the data of the customer? Is it going outside to train the base LLMs that we talked about, like the pre-trained base foundation LLMs? So there are a lot of steps that you can take in order to ensure privacy and data protection of your customers, data. It can start with encryption techniques. So you encrypt the prompt and the responses of like the responses that the model actually deals with. After that, data de-anonymization is something that is also required, which is to protect the identity of your user. So if I am using a chatbot and I'm providing it with a lot of confidential details that kind of exposes my identity, how do I as a developer make sure that this identity of my customer, of my end user is remain protected? So for that, we kind of add an additional layer so that I cannot gauge who's the person behind these details. So that is another part of it. Then comes implementation of PSM. PSM refers to Packet Security Manager. Packet Security Manager refers to a safe and secure requirement where you implement your GenAI solutions. So it's like you're cutting off the model and your application from the outside world, from the internet. So it works locally on your system in an offline mode. So it's like keeping your things safely in your own house, so that you protect it from external threats. So PSM comes into action for a very helpful use case. Then we also implement isolated networks, which is again like you are like operating from your own network, which is isolated from the World Wide Web. So there is less exposure to maybe potential attacks. So that's how we can implement the mechanism of protecting the data and maintaining privacy of the user's data. After that, let's talk about biased and harmful content. So many a times our models can generate biased information, conscious or unconscious bias information. So where does this bias arise from? So if we evaluate the performance of these LLMs, we find that it comes from the training data set, because when you collect the data, it's coming from the existing data set, which is already, you know, which is already containing a lot of bias, because these are open source data. So when you try to fine tune your model, let's do it in a way that we kind of eliminate all those bias that can reflect ultimately in our LLM responses. So again, that is a best practice to consider when you are uh, kind of preparing your training data sets, to eliminate any bias. Also, we can also provide prompts to our model, like at the back end, do sort of prompt engineering and tell that, okay, if you don't know any something, or if you don't if you're not aware about where this information is coming from, let's pause there and say that, okay, we don't know, instead of generating anything. Because generation of these harmful and biased content generally happens when the model try to make up something instead of actually knowing some information. So we can tackle to these two challenges, that is bias and harmful content generation, uh, with the help of like our training data set that we are feeding to the model. After that comes the black box model, which is a potential threat to uh, in general to the all the existing GenAI solutions, if we are kind of relying on it a lot. So if there is a lot of dependency of decision making on these LLMs, then this is a threat to human decision making capabilities. The problem with black box model is that you cannot, if you have like generated a lot of content from these models, and if you are relying on these outputs generated by the model for your decision making abilities 2 years and 3 years down the line, you won't be able to roll back and decide or analyze how the model actually came to this conclusion. So this can act as a very real problem for different industries, where you cannot figure out that how you arrived at this decision. So in order to prevent black box model and be mindful about this threat, what we can do is we can while we are generating the output, we can kind of break how the model is arriving on this final output. We can try to understand how the model is thinking, what's the thought process of this model behind the final conclusion. So for that, we implement kind of flank chain processes where we chain different outputs. So one output that is generated by the model is changed together with another output, and between this break, you kind of try to analyze the thought process of how this is actually getting implemented. So that was about the black box model and the techniques and mechanisms that you can adopt in order to consider all of these uh, potential threats, and in order to ensure that we are able to provide GenAI solutions to our customer in a more protected and private manner, by ensuring that their identities are remain hidden. And also, we are not sending the data back to the base models in order to train them. So Yeah, that was about it. Over to you, Praveen.
Thank you, Tisha. That was very wonderful. Yeah, I think let's jump into the live demo. So, where we are at now in the presentation is we started with understanding what these chatbots are capable of, what is their limitations, what is the benefits of thinking beyond this chatbots, and why we should take. We took marketing as a use case there, and we talked about the benefits, possible benefits, and then we looked at the back end, which is what the tech stack, which is the fine tuning, the RAG model implementation, and when we are doing that, what best practices that we implement within Linkenite, and then also we wanted to share with all of you. And with all that knowledge, what we came, just we wanted to show how the front end would look like, how the actual application layer looks like. And for that, we have created an MVP of the marketing bot based out of those principles that you just seen. So let me just share the screen here. So what we are seeing here is a bot that is locally deployed within Linkenite. And this is what is used by our marketing team to generate content. It is based on the training data set that we have created ourselves, fine tuned the model, and we also have the capability to make it rack capable. So if we want to add an additional knowledge sources on top of the fine tuning, we can also implement them. So what when the marketing person from our team starts, they could just draft like a simple text, like draft a blog on how human and AI can work together to build successful marketing campaigns. And this is the kind of the input. As I click send, the model is going ahead and generating and thinking through, given the previous examples, what type of a block content should be generated, and also making sure that Lincolnite's brand guidelines, the tone of writing is matched, and the formatting is kept intact. On the left here, we will have the editable content generated from the model, and then on the right, we will have a preview of the generated text. Okay, on the back end, it's visible. Oh, nice. Now it's the front end also visible. Thank you. So now let's go through the generated output and just try to understand what do we have here. So as I said, on the left side is what we have is a editable version, as this is more for assisting the marketing person to not have a blank page to while starting, but to have something to start with. Here, the marketing personnel can go through and read and correct if she finds something not correct according to what she would have written, or add more images or such here. So we can go onto internet and grab some images, and that should be possible to paste here as well. I do not have at the moment some images with me. But yeah, I think I could copy and paste images here as well. As you can see, also the formatting is quite intact. The marketing personnel in Lincolnite really likes to write more bulleted list, and then like to include quotations from famous personnel in, if in this regard available. And there is the towards the end, there is a call to action for Lincolnite is included by default, and this is more tailored to the content that is written above, and how Lincolnite service are able to um, help the personnel. This is more to show the possibility of the example, to be able to handle like sorry, the model to be fine tuned, and without any RAG implementation, how it can perform. And in this case, we have chosen a bit more capable model because we would want to have content that is more accurate and written very well compared to choosing a cheaper model, which is what chatbot would prefer because they would have a lot more interactions. Here, we would want model to really think through and follow the system prompts that we have built for this marketing workflow. But yeah, I think just to see like from here now the marketing personnel can choose to um, have the details removed or added, and then they are good to go. Copy paste, and this can directly be published into our website. Plus the it can be also used to generate different types of content here. But yeah, I think that is to the demo. Let's return back to our slideshow. If you have any questions regarding the live demo, or you would like to get a live demo like this, please do reach out. Um, okay, the next steps to really think about as we are in like towards the end. If you are based out of all what you understood today, if you are thinking of okay, I would like to implement this type of models and the workflows into your own organization, and this is here is a bit more of a thinking framework, how to think about it while making a decision. And for this type of solution, the first thing is just assessing your own needs. So looking into your own organization, it could be related to, let's say, writing research article, writing more technical white papers, or it could be something. And there you see, okay, that is where we spend a lot more time, and the resources we use is quite heavy on those. And we see, oh, this is still like a type of a writing where LLM technologies are quite good, and we have enough of the data from the past that we can use to. So this is where we are identifying a pain point where we are spending a lot of time, and it's kind of compatible with the LLM approach to be able to generate. And identifying these type of multiple use cases will give, okay, there is enough of the need that we should go ahead for our own organization and try to build this type of custom models. Then the second bit would be to more focus on understanding what is the budget that you should go for. So let's say if a researcher or a marketing personnel takes a half a day to go about researching content, and then take about 1.5 day to go about writing it and finalizing the blog or the white paper in a week or so or in a few days. If this approach could cut it down by, let's say, 50%, and that is like your kind of, okay, one day saved, we could either publish more content or we could publish more of the technical articles, or it could be that we could publish different type of contents now going on. So the time saved could be enhanced in just marketing or just save time that doesn't need to be paid anymore. And looking at different use cases that we have identified earlier, now we know, okay, how much is the budget for these things could be, because these are the potential savings that it could lead to. um, and combining these two, it kind of is a data flywheel. So whatever you are able to get to at this point, you will be eventually saving more, because as the data set improves for the given workflow, it's a data flywheel, and the AI model performs much better um, as it goes and gets trained more and more, working alongside the expert. So you would end up having to do less and generate even better responses going into the future. So always making sure, let's say if your cost benefit analysis come to like a 50-50, it costs about the same to do the implementation and then the running cost and such, then it's better to go ahead, because the technology will keep getting better and the data set that is also going to get better. So overall, it will end up yielding much more benefits than it will cost. And finally, the decision making framework, or what I would paraphrase it as like the implementation framework. How to start would be like, let's say now we know which use cases makes sense to do with the pain points, and then there is a possible benefits that will be yielded. Now to start with is a good small pilot work to, and this pilot work can be initiated along with Linkenite, where we can help you first of all identify the sources of data in the workflow, help choose the model, help choose the framework that would be more suitable. And once that pilot shows some results, then that can be presented to management to make it more broadly applied across, and making sure the upkeep and all. So that's the direction to kind of get started. So you need to have these kind of two factors sorted out before the implementation of even pilot can be thought through. um, but yeah, I think that is the way when to consider the custom solution can be decided. So just to kind of wrap up the discussions that we have. So why to go beyond the basic chatbots? Because they have limitations that are not suitable for specific use cases, and they end up compromising a lot of private data as well of the organization. So definitely want to have this chatbots to be out of your workflow, and the specific models which are trained with the specific data sets and more consideration to your workflow are chosen. And we learned more about the technical stack, the fine tuning, the RAG based architecture, and hopefully, furthermore, the best practices around this and how to go about implementing it. And in terms of also thinking when to go about implementing it, we saw the live demo. It took a while, took a refresh, but then it did work and it performed quite well. So similar to that, and as we said, this is more of a showcase of what's possible, and this can be pushed way beyond its limit, given the data set and the willingness that the organization has to pursue this further. With that, I think I hand it over to Jaspreet for a Q&A session.
Sure. It was a wonderful presentation, Praveen and Tisha. We really thank you for such an amazing webinar. Now, I would want the audience, if there's any question that you have, this is the Q&A session round. You can drop in the chat box, drop in your questions. Oh, so we have a question from Faizan. Mm. Faizan is saying that I have been in the translation and customer service industry. It would be great to know about chatbots for personalized customer experience. Praveen, Tisha, any one of you could answer this question.
Thank you for the wonderful question. I think so. Given the translation and chatbot area, like as the expertise, we use also like a lot of chatbots. Sorry, the translation services. There is, in my understanding, a lot of workflows where like we ask the questions like, okay, does the translation person is certified? Can I use it this translation in my official submissions? Or there are similar to this very critical questions that the marketing should handle from this point of view. So the customer support people can build a very good set of FAQs and can have a customer support chatbot live on the website that is more semantically aligned to the brand and is able to answer the questions, and that can be implemented through like a refined model with the chatbot interface on front of it. But this is where once again I would say like if used if any standardized chatbot is used that is already out there, it runs the risk that it does not align with the brand guidelines or the type of work that at the moment you're taking up. So the main work of the business is translation and chatbots and such, and it's yeah, maybe not answering the right question in the customer support area. So yeah, I would say really good application for this type of custom models implementation.
Do we have another question or more questions on the presentation that we have? Okay, so seems like we are good with the webinar. Thank you so much, everyone whosoever have joined the webinar. And if you have missed any of the points, if you have joined late, we will be sending the meeting recording in your emails. You'll just keep an eye on your emails, and you'll get the email soon. If you want to talk to us more, you can book a meeting, you can call us, you can email us. The details are already there on the screen. You can take a screenshot if you want. And you can follow us on LinkedIn as well as on YouTube. So, yeah, thank you so much for attending the webinar. We'll see
Thank
you
you,
in the
everyone.
next webinar super soon.
Thanks, everyone.